Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to take a look at Karen Kamp's favorite geometry activities. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI Technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. As I mentioned a minute ago, I'm excited to be joined by our panelist, Karen Kamp. Karen was instructor of mathematics education at Yale University for 15 years and previously taught high school and middle school math for 13 years. She's been a T-Cube national instructor since 1998 and has been author of materials for summer workshops as well as TI instructional websites. Karen speaks often on how to use technology effectively to enhance student understanding. So Karen, it's great to see you and hear you. Thanks for joining us.
I'm so glad to be here tonight, Mike, for the geometry grab bag.
We're expecting a large crowd, so your audio is muted. Feel free to send any questions to Karen using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. As a reminder, this session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues tonight, but in the event that you do, at the bottom of your screen, toggle the audio broadcast on and off. At this point, Karen is going to discuss our agenda.
We're going to begin with the question of why use dynamic geometry. Then we're going to explore geometry situations to confirm properties and visualize theorems. We'll do lines and transversals, triangular midsegments, a quick review of circle angles and interior-exterior angles, then the Pythagorean theorem and its converse, properties of parallelograms, and coordinate plane reflections. We will wrap it up with a capture carnival, and then Mike will do the webinar drawing tonight.
Karen, thanks so much. We're going to get all this done in 1 hour. And by the end of the webinar, we will be talking about a quick introduction to, again, dynamic geometry on the 84 Plus as well as the TI-Nspire. And we hope by the end of the webinar you will be able to drag and observe pre-made figures, confirm geometric properties and visualize theorems, construct unmess-upable objects, measure, calculate, and capture data to form and justify conjectures. So with all of that being said, Karen, let me give you control. Feel free to share your screen.
Okay, Mike. I think it's shared. There we go. I want to begin with the idea that all of the software that we're using tonight is going to be available for free. There's a 90-day trial software for both the TI SmartView CE emulator software and the TI-Nspire CX premium software. So head over to education.ti.com if you need to do that download. So the first question is why dynamic geometry? Dynamic geometry, which comes in all sorts of flavors, allows you to construct, measure, and manipulate figures. It allows you to do it accurately, give you visualization of geometric scenarios. It allows students and users to create many instances of a figure. So when you create a triangle, you're not just creating that triangle, you're creating multiple examples of triangles to explore by grabbing and dragging a vertex or a side. The other usefulness of dynamic geometry is it's going to allow you to be in situations that students use multiple strategies and find multiple solutions. The activities are engaging students in doing the math, which makes it more motivating for them and makes their learning more durable. The last thing is that when students are observing or calculating in geometry, that leads them to conjectures, which can then confirm geometric properties. Students can justify them and possibly go to formal proof if that's part of your lesson objectives. Okay, so I have all sorts of documents for you in the webinar document folder that you will get a link to when the webinar is over. But a quick how-to sheet can be found at bit.ly/howtogeom with uppercase H, T, and G. And that is, wait, where did it go? Okay, so that is a file that looks like this, where it runs through all of the key ideas and how to do the commands that you're going to have to do with Cabri Jr. and Nspire, and I'm going to take you through it as well. So let's begin with Cabri Jr. What you're going to do is you're going to use the Apps button. And once you have chosen Cabri Jr. from the Apps button, you're going to use your tool menus through the graphing keys. You're going to get menus from those graphing keys and press Enter to select items in the menu. I'm actually going to go over to the TI-84 emulator here. So this is TI-84 Smart View. And when you press Apps, you go to Cabri Jr. And Cabri Jr. is on the color version of the emulator. Cabri Jr. also works on the black and white TI-84 Plus calculators. The screen size is a little different, but it still works. So here's what Cabri Jr. looks like blank. The menus are found in the graphing keys. And when you move down a menu, you move down a menu using your arrow keys and press Enter to select a tool. Once you've chosen a tool, you select Clear to exit the tool. And the other really important key is the grab hand. That's going to allow you to grab part of your figure, a vertex, a point, a side, and move it around. And that's your alpha button. With TI-Nspire, we're not going to start there. That's not a good place to start. TI-Nspire, you're going to use your menu button and work through the menus like you normally do, choosing points and lines or whatever it is you want. You're again going to press Enter to choose a tool. And when you choose a tool, you'll notice a tool icon in the upper left corner. You'll press Escape to exit a tool. And in order to get the grab hand for TI-Nspire, you're going to do Control-Click, and that's going to allow you to grab something. You'll see right here that I grabbed empty space, which would be allowing me to move the whole screen around, which is not what I want to do. What I would do is I would come over to a open point and press Control-Click, and then I will be able to grab from there. Okay, so where we're going to begin is we're going to begin with this pre-made situation where I'm dealing with parallel lines or not parallel lines and transversals. The reasons why you might want to pre-make the file for your students is that it allows students to focus on the implications of what they're doing and not on the construction details. We will get to do some construction details tonight, so don't worry. You'll get to learn how to construct even if you aren't familiar with it. But a pre-made file is really wonderful when you don't have the time to do it and you want students to be able to focus on the implications. So in this TI-Nspire document, by the way, Mike, do we have, did the group tonight have a leaning whether they wanted more 84 or Nspire or equal measures of both?
Thanks for asking, Karen. I still have the poll open. Right now it looks like we're leaning towards TI-84 currently. Perfect.
I've got everything both ways, so we can choose our own adventure tonight. Okay, so here we are in TI-Nspire, and we were going to go over to 84 in a minute. But what I want to ask you, once you've done with the poll that Mike has asked in the polling part, I want to ask you why you think it might be helpful for your students to explore parallel and not parallel situations. Okay, here's a not parallel situation, and here's a parallel situation. And if you'd like to just put a couple things in the chat about what you might want to, why you think it's useful for your students to see them both. Okay, this is the parallel situation and the not parallel situation. On the Cabri Junior side, the Cabri Junior is a junior program. It doesn't have multiple pages, so I have to have parallel and not parallel as two separate documents. Okay, so Karen is saying in the chat that when you have a not parallel, when you have a not situation, it tells you a lot when you're checking a conjecture. You can compare and contrast. Okay, you can focus in on angle relationships. Okay, so in Cabri Junior, I'm going to hit open, and I want to open up parallel or parallel not. Okay, so in parallel, whoops. Actually, Mike, I think the poll just popped in. There we go. Okay, in parallel, what I want to do is I want to move my cursor over to a point and see what happens when I move it. And in Cabri Junior, we don't have a message that pops up and tells us what we are doing, whereas at TI-Nspire we do. But there is a way that Cabri Junior communicates to you. If you notice carefully, as my cursor got close to point B, nothing happened. But here at point A, can you see what's happening? The point is blinking at me, and my cursor has become hollow. That means that I have the opportunity to grab this point. So I select alpha, and I can move point A, and we can see what happens. Whoops, that 115-degree angle, this angle measure right here is actually in the wrong place. It didn't move with the others. Okay, so here's the parallel situation, and then I can open the parallel not situation. And I ask students targeted questions when we're discussing these situations so that they're not just watching the math go by. In this scenario, point B turns out to be independent and can be dragged. So what happens when I drag point B? I'm changing some of the angles. I press clear to let go. If I go up and choose point A, we can see that some angle relationships will hold, but some angle relationships won't hold. So the targeted questions that I ask my students is how many angles are there being created when when one line intersects another line, and how many are created when one line intersects two lines. So I want to focus my students on the 4 angles and then the 8 angles. And what you will find out is that in the lab sheet, most of these activities, and all of these activities, have a lab sheet that goes with it. So I ask the students how many angles are formed, how many angles are formed when you intersect 2 lines, which angle pairs remain congruent as the position of the transversal changes with parallel lines, not parallel, and then ask students to do some always, sometimes, or never. What are your conclusions? At the beginning of the lab sheet, I just have a little box for students to record some of their observations. And this is one of the really important points. When you're using dynamic geometry, you can't just leave it to chance that the students are going to either focus on what you want them to focus on or remember what it is that the lesson was teaching. So by giving students some sort of a template to record observations, this can be done in person, if you're in-person teaching, or if you're doing online teaching, you can have students making notes in a notebook, in a Google Doc or a Word doc, or any other place that you're doing it, but give them that opportunity and that requirement to record what they're doing. It allows them to keep track of their thoughts and their conclusions. At the end of the lab sheet, there's a summary of what's happening, what was the learning that we want them to know, and that it's important as the teacher to make sure that the class gets that summary, whether you're doing the summarization or a student or group of students. When we were teaching in person, we would have a class, easel chart, and that easel chart would have all of our conclusions on it, or keep a Google Doc of those conclusions. What I found out is that it's really, students will lose what it was we were teaching. They'll remember we were using the calculators, or they'll remember we were using this particular software, but they won't remember what it was, the geometry that I wanted to teach. Finally, don't be afraid of students going off to discover different things about a scenario that you hadn't thought about. And let's go to our next activity. The next activity is a triangle mid-segment activity, and the pre-made files are already created for you, but I wanted to show you how to do some construction on your own. And the triangle mid-segment activity is a really nice one because it allows students to get their feet wet with constructing and measuring. The pre-made files are here if you need them. Hang on a second. Sorry, I've got my new file. Now I want to get a triangle tool. So the triangle tool, hold on a second. I got to make sure I'm going to look at the exact thing that I want. Okay, triangle tool, I want to make a nice large triangle. And as I'm starting to do this, think about whether and when you want students to label your geometric figures, because it's really easy to label them in TI-Nspire, and it just takes a little bit longer to label them in TI-84 Cabri Jr. So what I tend to do is I don't have students label their vertices unless it's really essential to the setup. But I'm making a nice big triangle here. And I see as I'm doing this that Daniel has discussed the idea of notice and wonder. And asking students what they notice and what they wonder about a situation is really important. Okay, so once I've constructed this, in Cabri Jr., I go to the Graph button. I select Alf Num tool. And then I have to press Enter to start my label. And this one in my diagrams in the handouts is C. So I'm going to type the letter C. The alphabetical key is already active, so I just have to type the button that has the C above it. I press Enter, and I'm going to arrow over. And it takes a minute to do it. With Cabri Jr., you can attach through a link cable an actual calculator, and you can run it from the calculator keypad. It makes it a little bit faster. The other thing is I don't want this triangle to be too isosceles looking, so I want to pull point B a little bit to the left. Since I have my tool active, I can't grab that point B, so I'm going to press clear from the alphabetical tool and get my grabber hand, which happens to be the alpha button. I just don't want this thing to look too isosceles. Okay, and when I'm done with that, I press Enter or clear to put it down. And now I'm going to go up and label my last point. And we're hopefully familiar with geometry, even if we're not all teaching geometry at the moment. Think about what things you're going to want to measure on a triangle with a mid-segment. Okay, so here we go. We've got triangle ABC. I want to create two midpoints. My construction tools are here in the Zoom, under the Zoom button. They're in the construction menu. And I want the midpoint tool. And the midpoint tool can either find the midpoint between 2 points, or you can select a side or a segment. So I want the point from point A to point C. Look at that midpoint that's appearing as I'm going. Kind of cool. And I got to get all the way over to point C. Press Enter. Notice that point C blinks at me, so I know I'm getting point C and not just a point near point C. Okay, and so I'm going to get over to the other side. Watch what happens when I get to the other side. Cabri Jr. asks me, do you want to use this side? And there it is. The side is blinking at me, and I press Enter, and I've got my point there. Okay, clearing out of that, I want to get a segment, which is my mid-segment. So what are some of the things that we would want to measure? We would want to measure an angles. We might want to measure distances. Window button gets me the F2 menu for me to get a segment. And that from that point there, over to the other side. Okay, let me just get some quick distances here. Graph button gets me the measure menu, distance and length. I want to measure this segment. Press enter again to put the measurement down. When I get to side BC, look what's flashing first. The whole triangle flashed for a few seconds, then the base flashed. Cabri Jr. is asking me, do you want the whole triangle measured at the distance, which is perimeter, or do you just want the base? And I just want the base. I can push, I believe it's the second button that toggles between them. Whoops, I did it too fast. So I want to delete that. Okay, and then back to measuring. Okay, and I just want the measurement of the side. There we go, it's 20.2. Okay, so I think that you can see pretty quickly that this mid-segment looks very much like it's going to be half of the opposite side, the third side. But the key thing with dynamic geometry is dragging and moving, grabbing and dragging and observing. And watch what happens as the triangle changes. Can you see those differences? Do those relationships hold true? Let me show you what is already pre-made in the other files. Midseg is the base file with no measurements. Midseg 1, oh, it's asking me, do I want to save changes? I need to type a name. You get 8 letters to type here. I'm just going to call this mid because I don't want to type out a long name, but there's mid. Here is the midseg 1, which has slope, and it has angles, and it has side lengths. So this is all set up for the first problem in the student worksheet. Something is not right with those angle measures. Oh, there we go. I was going to say the angle measures weren't changing, but they are indeed changing. There we go. Okay, the slopes are changing. You can talk about parallel, you can talk about corresponding angles, and you can talk about half the distance. And the third file that is available is midseg 2. And look at this one. This one has areas and perimeters also pre-made for you. Just looking at it isn't the power. The power is in dragging and observing. One more thing besides dragging and observing that is critical to using dynamic geometry is the concept of whether you are drawing a figure or constructing a figure. When a figure is accurately constructed, we call it unmess-upable. It's guaranteed to keep its properties no matter how it's dragged on the screen. Some points might be dependent on others, so we won't be able to drag them. So for example, if I come over to point E, which is a midpoint, I can't drag it because it is dependent on the locations of the endpoints of the segment that it's on. So E won't drag. I can't get E to blink at me, although the vertices of the triangles I can. Same thing, a right triangle will need a perpendicular tool to be constructed properly. If you're only using a triangle tool, then you are making it look like a right triangle, but it won't stay a right triangle or keep the properties when a vertex of the triangle is dragged. Okay, so those were our first 2 activities to talk about examples and non-examples so you can compare and contrast. And the Mid-Segment Explorer, which gives students an opportunity to learn some simple construction tools and do the notice and wonder. What else do you want to measure here? What else do you see? How else can you explain this? So some students understand that we've been teaching them that the mid-segment is parallel to the third side, but we have a slope, which is a measurement that helps us do it. We're going to jump back to the PowerPoint because what I use a lot in my teaching is the idea of the action consequence reflection cycle, where students perform a mathematical action, observe a mathematical consequence, and reflect on the result and reason about the underlying mathematical concepts. So the reflection piece is the most important component of this, and that underpins a lot of what I do with students to make sure they have ample time to reflect, make predictions, and come to conclusions about their geometric scenarios. Okay, so if you saw in the agenda, I said that circle angles and interior-exterior angles were things that I was going to quickly review. And the reason I'm going to quickly review them is because I've discussed them in past webinars. But let me just show you them. Let's jump over to TI-Nspire for a minute. Here's a picture on TI-Nspire of a circle inscribed angle and the arc. And what we can do here is we can create the angle that's the central angle. I don't even have to put in the segments in order to measure the central angle. But of course, it's going to be easier for students if they can see a central angle. And under geometry, we're going to measure an angle. Anytime you're measuring an angle in geometry, you need to name or select 3 vertices or 3 points with the vertex in the middle. Okay, so here we have that circle angles, and you can see, and students can discuss what's happening with those measurements. These are going to round off to the nearest degree, which is how this particular file was set up. In Cabri Jr., I actually did some of the measurements. I have the measurements done on the circle angle. Let me show you interior, exterior again. Very, very quickly. This file has all of the interior angles and 1 exterior angle selected or measured on this triangle. And when students drag and observe, they're going to be able to take a look at how the measurements update in real time or don't update in real time. And this process is known as something that is invariant. What we notice is that the 2 remote interior angles add up and they change, but the sum of all 3 angles don't change, and the sum of the exterior and the adjacent interior don't change. They're being dynamically updated, but their sums don't change because they're a geometric invariant. So there's lots more that you can do with these, but like I said, those were in some other webinars, so I'm going to move on. When you're in the geometric environment, what you can do is you can ask good questions. What will happen if I make an obtuse triangle? What will happen if I have a right triangle? How is one thing affected by another thing? What must I change to make something happen? What changes, what stays the same? When will something be true? Why is this true, and how can we prove it? Is it even important to prove it? Okay, we're going to move along to the biggie for tonight, which is the Pythagorean theorem. And I want you to think about things that you might want to give students as preliminaries. What are important preliminaries for your students? Do you need to make sure they know the definitions of interior and exterior angles? Do you need to remind them to make different kinds of triangles? I know that with my students, I always had to tell them to drag a point and observe what happens, because if I didn't tell them that, everybody wrote down all the same angle sizes because nobody had bothered to do it. They didn't get that that dynamic movement was really, really important. Okay, so the Pythagorean theorem, there's 2 parts to the Cabri Jr. activity, and there's 3 parts to the TI-Nspire activity. So let's go to the TI-84 Cabri Jr. activity. And many of us teach this diagram of the Pythagorean theorem. where we have squares built on the sides of a right triangle. These squares, I can't drag the squares themselves, but I can drag the triangle. So I got to get over, okay, to a vertex, and we can see what happens when these the squares are representing the square of the side, their areas. And here's a nice setup right now where I can tell that adding up the two smaller squares equals the square on the hypotenuse. We can actually do a calculation in Cabri Jr. When you calculate in Cabri Jr., you use the graph button to get this menu here, the F5 menu. Choose Calculate, and you move to any numerical value. I'm going to choose the smallest leg square, enter. Then I have to choose an operation. I'm going to add them. Notice up here the tool icon has changed to an adding tool. And I'm going to choose my second number. And finally, I'm going to press enter wherever I want my sum to land. I'm going to clear and use my grabber hand again to see what happens. And this file has, you may want to do that calculation for the students so that they don't have to do it for themselves, but you can see that the sum of the two squares equals the third one. We're going to jump over to TI-Nspire in just a minute to see the same scenario over there. But I want to show you before I leave Cabri Jr., I just want to show you, I love, one of the earliest things I did with dynamic geometry was a lab on the converse of the Pythagorean theorem. And this is not a right triangle, right? So how is this going to help me with the Pythagorean theorem? Well, it turns out if you apply the Pythagorean theorem with the longest side as C, you will be able to determine whether you've got a right triangle, an obtuse triangle, or an acute triangle. So I have students filling out a lab sheet, gathering data from a figure, okay? Make different types of triangles, tell us what the three sides are, square the two sides and add them up, and square the third side, and figure out the conditions that make this true. When students are doing this scenario, and they're doing that calculation themselves, it becomes really powerful learning for them. Let's jump over to the TI-Nspire version of this. Okay, so TI-Nspire has the benefit of having extra pages in the document. You can have multi-page, multi-problem documents. And so the extra that I have at the beginning of this Pythagorean theorem lab, I've constrained this triangle so it has integer sides. And so what's really nice about this is that I can see what happens with integer values. And we can even, if we're very careful, get some nice Pythagorean triples showing up here. Okay, 6, 12, 16, 20, or 5, 12, 13. So this is just a Pythagorean theorem generator where the students don't have to do the math. The TI-Nspire is doing the math. And what you can do with this is you can actually on TI-Nspire have a split screen calculator and work through some of the values. And this next page has some values measured, and students can actually capture the data and confirm that the Pythagorean theorem works. We're going to talk about capturing data at the end of the hour, so I'll come back to this. Let's go take a look at the Nspire version of the figure I showed you before. This one, again, you have to remind students to drag and observe. Okay, change things up or else everybody's going to have the same values. This one has been created so that your open hollow points are the ones that are grabbable. And we can show the sum of my squares. And notice that sum, the sum is going to change as the figure is grabbed and dragged. I see in the chat whether there's going to be things, the PowerPoint and the agenda are going to be in the webinar documents, and absolutely, you're having so much in your webinar documents. Let me just give you a quick peek. You're going to have 9 different folders of activities. You have Nspire files, TI-84 files for both color and black and white, and a bunch of slides and how-tos. So there's tons of stuff for you in the webinar documents. Somebody else is asking about how do you keep your classes engaging and interesting while you're online. So when I'm doing this online, when I was in person with students, there were circumstances, and I know that certain teachers have this circumstance where not every student is holding a calculator or has the TI-Nspire software on their computer. So a good deal of this can be done by demonstrating it and projecting it to the class, even if everybody doesn't have their own. By having the lab documents that students are writing down notes, it's engaging them in thinking through some of these activities. They've got things to do and things to think about. And like somebody had suggested, using the notice and wonder prompt, what do you notice here? What do you want to measure? What do you want to find out? Really helps students attend to the different parts of the geometric scenario. Okay, so the third problem in the Pythagorean lab on the Nspire is that converse. And TI-Nspire has these nice sliders so we can make our values show up. Here is our a squared plus b squared, and here is our c squared. So c has to be the longest side. Hold on, let me grab my point. Okay, so here we have an acute triangle situation, and you'll see that a squared plus b squared is bigger than c squared. If I go all the way out to obtuse, we'll see that c squared is bigger, and we'll see if I can get pretty close to right. Not too bad. Right triangles, it's exactly equal. Okay, with this Pythagorean lab, this is a several-day operation here. I want you to think about what parts you want to make more dynamic to your students. Is it the knowing about the Pythagorean theorem in this situation? Is it the proving it or justifying it with the squares on the sides? Or is it the converse? I love the converse as an investigative lab. Okay, onward to properties of parallelograms. Looking at it in Cabri Jr., I have 3 files here, parallelogram 1, 2, and 3, and each one of these has a different set of measurements that is already set up for your students. And like before, you want to encourage students to grab and drag and observe what happens. What happens to the side measurements when I move point Q? Whoops, it's not going to go that way. Depending on how this was constructed, point Q is not going to move in all directions. In a minute, we're going to talk about constructing this. The parallelogram 2 has angles measured, and parallelogram 3 has diagonals and their individual segments measured so students can notice that they are bisected. Now, I love quadrilaterals, and the years that I was teaching geometry, I would often do my entire quadrilaterals unit online with dynamic geometry. I don't even mean online, excuse me. What I'm trying to say is with the technology. So I would have students construct, we would all construct the parallelogram ourselves together, and we would discuss all of the properties of parallelograms. And once my students were, accomplished at that and knowing how to do that construction and how to do all those measurements, I would set them loose. Different groups, one group had the rhombus group, one group was a rectangle, kite, square, and your job was to construct it, make it unmess-upable, and find out all the special properties of all the special quadrilaterals. I just wanted to show you quickly how to do construction straight in TI-Nspire. You'll see it's a little bit more smooth than the TI-84, but if you've got the Cabri Junior, it's a great junior program. If I want to start with 2 segments with a common endpoint. And in TI-Nspire, it's really easy to label. You begin by labeling, as soon as you put down a point, you label it by typing that letter. So I'm going to make point A and point D here. And the first side I'm going to create by constructing a parallel line. It's going to need me to press enter or click on a point and on a straight object, a segment or a line. And with my grabber hand, I can extend this line. Some people are bothered that TI-Nspire doesn't have arrowheads on it. Arrowheads are used for vector objects, but there is that line. The next thing I want to do is I could do another parallel line, but I want to show you one more construction tool, which is the compass tool. And the compass tool works just like a compass. It says, what is the distance you need to measure? And so I want to measure from A to D. And then watch this. This circle is my compass. And this circle is going to get me, I'm going to center it at point B. And I'm going to get the intersection point that's going to make the 4th point of my parallelogram. Actually, there's 2 intersection points. One of them I don't need. If you don't want a point to show up, you can hide it. Okay. And let's get my segment. And here's my segment. And that point is C, which I did not label before. Let me clear all my tools. When you want to label in TI-Nspire, the menu item is under Actions, number 7 Text, and that's going to be our point C, and you have to press Enter, and then you can hide things that we don't need. Actually, if I hide that line, I won't have a segment there. Okay, in any case, you can see how quick it was to construct that parallelogram. Let me just show you under Actions, number 1. Whoops, I got an extra menu here. Under Actions, the Hide Show tool hides and shows me in gray everything that I had previously used. So I'm going to just throw that line right back in there just so that we don't have an empty parallelogram. But the TI-Nspire allows you to do a whole bunch more with this diagram, and the previous pages in this were having students do the same things, measuring and finding out what the properties were. What is really powerful is that once students have these tools at their disposal, even if it's just the grabbing and dragging tool, you can explore less common properties because the technology is doing the heavy lifting for students. So you can explore what kind of figure is created by connecting the midpoints of a parallelogram sides, or what features there are when a quadrilateral lives inside a circle, cyclic quadrilaterals. And like I said, you can explore special quadrilaterals. So I've found that dynamic geometry has allowed my students to tackle really some advanced geometry topics. I had a low-level geometry class that explored points of concurrency in triangles, or some of the angle and arc theorems that we never would get to otherwise. Okay, the next idea is that dynamic geometry also lives in a coordinate environment. And how can we use the coordinate environment to learn about our figures? So I've chosen to do some reflections in a coordinate plane. Let me actually just jump back to Cabri Junior. Where are you, Cabri Junior? Here we are. And again, Cabri Junior can't give me multiple pages in a document, so I made a reflect over the x-axis figure, and then I would make a reflect over the y-axis figure. So when you see this, I labeled my points, my vertices of my initial triangle, my pre-image, but I didn't bother labeling the vertices of the image because as long as you're dealing with a very scalene triangle, you can, as long as you're not dealing with something that's too equilateral, you can see what's going on. And this is another good question for students. What do you notice? What do you wonder? What other measurements do you want to take? Do you want to find out some other coordinates? So if I come down here, you'll notice, by the way, that when I get down to the image triangle, I will not be able to pull and drag on the image triangle. Okay, that point there is dependent on the pre-image. So I will not be able to pull and drag. I don't get that highlighted point or the open cursor. If you want to measure a coordinates on Cabri Jr., it's in that graph menu, coordinate and equations, and here's where you can ask students, make a prediction. And are we surprised? Not so much that that is the, it's related to the original point C. What has changed? The y value has changed because when you are reflecting over the x-axis, you're reflecting in the vertical direction. I spent a lot of time talking about what is the direction of the reflection, not what axis is the reflection. In the other Cabri Jr. file, reflect y, I think this one, I got all the coordinates for you, so it's already set up that way. In the handout for students, it not only asks about what happened to the coordinates, but it asks them what else do they think might be true. What do you think is true about the sides and angles of your original triangle and your image triangle? What do you think is true about the area of it? What do you think would happen if you reflected over the x and then the y? What do you think would happen if you tried to reflect over the line y equals x? So the lab worksheet asks students to think about these other scenarios. The TI-Nspire activity is really fun because it has just a quick arrow clicker that you can get things reflected, and it is really easy to get coordinates and equations. All you do, it's in the Actions menu. You can get the coordinate and equation tool, so I can select a tool and get that point. I pressed enter, and then it's going to ask me to press enter again wherever I want to put it down. Whoops. Sorry, I lost my image. Okay. And then I can also get the coordinate and equation of the other. Here we go. I can get the coordinate and equation, the coordinates of the image. The other way to get a coordinate in TI-Nspire is you can right-click. Right-click, if I'm holding a mouse, I literally right-click, and I get a pop-up menu, a context menu. And if you're not holding a mouse, you do it by hitting Control Menu, and it will give you a context menu for whatever it is you're pointing at. Okay, so this file with TI-Nspire has a lot more. It has a whole bunch of different types of reflections and rotations, including reflection over the line y equals x and rotations about the origin. So there's a lot of fun things in that one. Okay, we are starting to run short on time, so I want to show you a couple of last things. I want to show you how TI-Nspire lets us really visualize scenarios. One of my favorite TI-Nspire activities, this one doesn't have a TI-84 counterpart because there's too much going on, but this is going to allow students to really investigate why do area formulas work the way they do. So here we have a rectangle. I can change the base and I can change the height. And I love how this file asks students right in the file to observe what happens. And the parallelogram is created to match that base and height. And then they say grab point P and slowly pull it to the right, what happened? Wow, point P is going to allow us to sort of chop off this triangle, bring it to the other side, and discuss with students what is changing. Is the base and the height the same? How are these area formulas related? Here's one with area of a triangle. And what they have us do here is grab point Q, pull it around, and now two triangles make the parallelogram. And of course, you could have changed the parallelogram in the first place, okay, to make it look more like a parallelogram or more like a rectangle. So lots of really wonderful things in this area of formulas. There's also a trapezoid, which is really fun to discuss. Why does this work? How can I justify this? There's a lot of good exploring and thinking and justifying that students can do in it. Okay, the last concept for the night is the idea of a capture carnival. We've done calculations. Those calculations have confirmed properties and bolstered our conjectures. But now I really want to show you the power of the TI-Nspire where we can capture data. I wrote some blog posts, which is what this webinar has grown out of, and two great activities that we're not going to do tonight, but they're in your documents for the webinar, is a document that is called Circumference, Area, and Diameter, and it lets you capture the data on a circle, and you can get a linear relationship between circumference and diameter, or the quadratic relationship between area and radius, or area and diameter. There's also a problem called the garden area problem, where students model building a garden along a wall. So you have a set amount of fencing to work, and what can that area be? And we're going to create a quadratic model, and do you want to optimize it? So there's some really wonderful real-world problems that can be modeled using geometry figures and data capture. And don't despair if you're using TI-84, because you can still gather the data and put it into your lists and get a scatter plot and do a regression and do all of the things that you might otherwise do with TI-Nspire. But in our last few minutes, I want to show you actually how you can capture data, and TI-Nspire connects all the pieces for you. So here we're going to discuss chords in a circle. This is one of those throwaway theorems in my geometry book. It's like there's a section in the chapter on circles, and it's hardly even a theorem about chords and their distances from the center of the circle. Students pretty much can see that a radius is going to be the perpendicular bisector of that chord, but my question is, how does the chord's length depend on the distance? And so as I move around, you can see here my chord is very long because I'm not far from the center of the circle. And here my chord is very short as my distance is getting longer. How does that actually mathematically work? So what you might notice is that these words, distance and chords, they look bold. And the reason why they're bold is because those measurements were stored as variables. If I hit the variable button, oh, there's a lot of things here because I've done some stats with this, but chord and distance were stored as variables. Then on the next page, I have a spreadsheet where my data can be captured. I can do it manually, which is how it's currently set up. And the way that you capture a data point manually is you press Control, decimal point. And let's check out that spreadsheet. Now I've got another data point. I can do it automatically. You'll notice here that my capture was done, and I have a 0 here. That was a manual capture. I'm going to change this to an automatic capture. Menu, Data, Data Capture, and I'm going to do it automatically, and that's going to change the 0 to a 1, and I want to capture the distance. It's going to overwrite my data. Okay, and this one I can actually just edit it right here. I can change it to a 1, and it's going to overwrite some data. Okay, so I like the manual data capture with students because they can select specific data points to choose. But for us, let's go wild with the automatic data capture, get very small and very big, and let's see what happened. Wow, I've got a full spreadsheet here. This is a data and statistics page, which I had previously set up, so that's why the data is showing up right there. And this is a scatter plot page, and I really like the graphing page, scatter plots, because I can work with this, and it turns out that we've got a relationship which is a square root relationship. And so what you want to do is you might have students figure out what the geometry might be, and we can set up the relationship. Actually, instead of the 2, let's make that A. And this is going to be, that circle in there was a radius of 8. So I'm going to put in a 60, actually, I gave it away. I didn't want to do that. Sorry. B squared minus x squared. When I put in parameters like A and B, TI-Nspire is going to ask me if I want sliders. And so what I can do is I can change point A to 2, and B, I need to change the slider settings to let it be as big as possible. And we can actually, whoops, I should have made that, it was squared. I made that too big. Sorry about that. I should have made it 10, not 100. Oops, that's even worse. Okay. Okay, so here we go. I wanted to try, you can have students slide this to see where it's going to land. Okay, and it's getting there. But let me just get to the point. The punchline is that the formula is going to be 2 times the square root of the radius squared times x squared, and that's going to match that data exactly. So data capture is a really, really wonderful way to extend what you're learning. Let me get back to our PowerPoint and wrap this up. There will be helpful hints for you in your documents, your webinar documents. Choose your tool first, construct versus draw, be patient. And then some tips for online teaching. Keep your 84 Smart View or your Nspire Premium software on top of your working document. So if you have a Word document or a Google Docs, keep that underneath and you can have your Smart View on top. Use screenshots frequently so students can keep up and catch up. Annotate your work for asynchronous students. Use color and motion to highlight ideas and address misconceptions directly. Do that both for synchronous teaching and when you're recording. And provide templates for students to record their observations and reflect on the geometry concepts. Summarize the results for the class. That summary is what's going to make that learning more durable and longer lasting. It's going to make it stick for the students. You can do the summary or the students can do the summary, and it's better to let them do it, but don't let the learning activity end without some conclusions. What did we notice? What did we find out? What did we learn? Can we show it another way? And are there more questions we want to explore with this scenario? Okay, please contact me. You can find me on Twitter at Karen Camp. You can email me, karen.camp@gmail.com. If there's something you're missing in the webinar documents that you want, I tried to include Word files so you can edit them to work for your students and your needs, but let me know if you need them. And my blog is Reflections and Tangents at karendcamp@wordpress.com. There's the blog for you. Please join us the next 3 Saturdays for the T-Cubed International Conference. That is all virtual. And Mike, I think I went a minute over, but I think we got a huge geometry grab bag.
Karen, thanks so much. Karen, I'm going to steal things back real quick.
You bet. I tried to give it back to you, but I wasn't fast enough.
No problem. To receive a certificate of attendance for tonight, please go ahead and click the link in the chat window. Also listed is a link for the documents that Karen put together, and there's a lot of them. So please take a look through those documents that she put together for tonight. And if these links aren't working for any reason, hang tight. You'll automatically get a follow-up email in a couple days, and that follow-up email will contain a link to the recording, a link to the certificate, as well as a link to the documents. And if you're watching this on demand, copy that link into your favorite browser to receive your certificate. As Karen just mentioned, we're excited that the next 3 weekends will be engaged in the T-Cubed International Conference. Please visit our website to learn more. But we are giving away to one lucky winner a T-Cubed International Conference registration. And tonight's lucky winner is R. Ronan. So congratulations. We hope to see you at the T-Cubed International Conference this weekend, as well as everyone else. We'll be in touch over email in the next couple of days, R. Ronan, to give you a little more information. Karen, thanks so much for putting all of the documents together in that huge grab bag. I forget what I saw Benny St. John. I don't think he called it a grab bag. It was something, but grab suitcase, that's it. So thanks so much for putting all this together for us in that suitcase.
It was my pleasure, and like I said, if the suitcase doesn't have something that you need, just reach out. I'm sure to have it for you. Take care, everybody. It's a tough time this year, but it's been so much fun being with you tonight. Hope you'll join us at the T-Cubed International Conference next couple of Saturdays.
I echo that. Thanks so much, everyone. We're going to take a Tuesday webinar break for a couple weeks. We'll be back online after the T-Cubed International Conference. Talk to everyone soon. Have a great night.